Hello students. So let's review real quick what we learned in our last lesson. The law of sines, which I'm abbreviating LOS, tells us that for any triangle, whether it's acute, right, or obtuse, side A over the sine of angle A is equal to side B over the sine of angle B, and is also equal to side C over the sine of angle C. So when you use it, you're going to use two of these three ratios. Let's imagine that you're using this one and this one. And so you're going to need three of the four unknowns. Maybe you have two sides and one angle, and you can solve for the missing angle, or some combination of three of those four things. So what do we do if we have a different combination of information? Is there another way to solve triangles that uses maybe all three sides, for example? And there is. It's called the Law of Cosines. So in today's notes, we're going to write down the Law of Cosines and practice using it. And to save time, I'm presenting the proof in a separate optional video. So those of you who are curious and would like to see where this formula comes from, you can watch the other video. Those of you who just don't have time to do that, or you're not interested, you don't have to watch that video. Okay, so I present to you three versions of the law of cosines, and you're only going to use one of these versions at a time. It just depends on the given information. So what we see is that each of these formulas involves all three sides. Notice you have side A, side B, and side C, and additionally it involves one angle. So let's imagine that you have your triangle ABC. And if you know the measure of angle C, and you know side C and let's say side A and side B, or if those are the four things you're interested in, then you can go ahead and use that version of the formula. So if I know angle C, I'm going to use this version. However, if I know angle B, I'm going to use the second version. And if I know angle A, I'm going to use the third version. Or if I know all three sides, but I want to find angle C, I'm going to use the first version. If I want to find angle B, I'm going to use the second. And if I want to find angle A, I'm going to use the third. So let's practice this and you can see how it works. We're also going to continue to store in our calculators and use stored values to help us approximate with accuracy. And you're going to find as we do the problems that we'll use the law of cosines at first, and then once we have enough information, we switch over to using the law of sines because it's simpler. Okay, here's number one. We're going to give approximate answers and round them to the nearest tenth. So what we know about this triangle ABC is we know the measure of angle A, the measure of side B, and the measure of side C. And we want to find all the rest of the parts. So we're solving the triangle. And because we know the measure of angle A, we're going to use this form of the law of cosines. A squared equals B squared plus C squared minus 2BC cosine of A. So let's go ahead and substitute all of the information we have into that. So A squared equals 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 35 degrees. I do want to simplify this, but I'm not necessarily going to find the cosine of 35 and write that down because that would be approximate, and I don't want to approximate until the very end. So actually, come to think of it, there's really no need to simplify this expression right now if you're just going to put it into your calculator and then square root it. So put this entire thing, you can do it all in one step, make sure your calculator is in degrees, put entire expression into calculator. Don't forget to square root it because this entire expression is going to give us A squared. We want A. So let me show you that. So we have 15 squared. Oh, I should check my mode. Yep, I'm in degrees. Okay, 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 35. Don't accidentally do sine. This is the law of cosines, and it involves cosine. So that number, and then to square root that, we can do our square root. Second square is square root. And then we can do second negative sign right next to enter. And what that does is it puts your previous answer inside the square root sign, so you don't have to type it in or lose any accuracy. Okay, let's round this to the nearest tenth to write it down, but let's store it so we can use it later. So press store, alpha, A, enter. Okay, 8.9. Now let's move on and let's find the measure of angle B or the measure of angle C. So now that we know a pair, we have A and A, side A and angle A, we can use the law of sines. We could use the law of cosines if we wanted to, but it's easier if we use the law of sines. So let's switch over to that. So we're going to do A over the sine of A equals, now we need to do two things. We need to find angle B and we need to find angle C. So does it matter which one we find first? Well, you might remember from yesterday's lesson on the law of sines that you can run into trouble when finding the largest angle because your calculator might give you the supplement of the angle you want. So to avoid that problem, I'm going to avoid using the law of sines for the largest one. The largest one would be angle B, since side B is the longest. So instead, I'm going to use side C. So I'm going to go with C over the sine of angle C. So we'll fill in our numbers, but we're going to use the stored value of A. So 8.9, I'm going to put an asterisk, which means don't forget to use the stored number. Don't actually use 8.9. Over the sine of angle A, 35 degrees, equals 10 over the sine of angle C. Okay, so let's cross multiply. Stored 8.9 times the sine of angle C equals 10 times the sine of 35 degrees. Divide both sides by the stored number. And then find the inverse sign to get C by itself. So this is what I'm going to put in my calculator, this entire expression that I'm writing right now, all at once. I'm not going to put things in my calculator until I get to this point. So let's see what that looks like. So we have inverse sine of 10 sine 35, close those parentheses that opened before the 35, divided by alpha A, to recall the number I stored, 40.1. And I'm going to store this. Store alpha C. I'm going to write it down as 40.1, but I'm actually going to use the stored number to do my next calculation. The last thing we need is the measure of angle B. And to get the measure of angle B, we can take 180 degrees minus the measure of angle A, minus our stored value for angle C. And we're going to get an approximate answer. 180 minus 35 minus alpha C. And we'll round this to 104.9. See, it did turn out to be obtuse, and so it was a good thing that we avoided using the law of sines to find this angle, because the calculator wouldn't give us, when we use inverse sine, it wouldn't give us an obtuse angle. It would only give us the supplement of that. Okay, we're going to do one more example. So in this first example, you saw that we used the law of cosines to find a missing side. Next, we're going to use the law of cosines to find a missing angle. So here is the problem. We're going to find all three angles. So we're going to solve the triangle so that in the end we know all three sides and all three angles. But because we know three sides right now, we can't use the law of sines. If you know a pair, a side and an angle, and then something else, you can use the law of sines. So instead we're going to use the law of cosines. Now, here is a good time to find the largest angle. With the law of cosines, it doesn't matter which angle you find. The calculator is always going to return the correct answer to you. But we know with the law of sines, we run into trouble with obtuse angles. So why don't we avoid that and look for the largest angle first using the law of cosines. And the largest angle is going to be C because side C is the longest. So if we're looking for angle C, we're going to use this version. C squared equals A squared plus B squared minus 2AB cosine C. So let's fill in our numbers. 20 squared equals 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of angle C. So it's going to be more difficult algebraically to isolate letter C in this equation. So watch carefully what we do. Sometimes people make order of operations errors here. So what we could do first, if we want to just make this easier on ourselves, is go ahead and square the numbers. So 20 squared is 400, and 12 squared is 144, and 17 squared is 289. And we can multiply 2, 12, and 17, and we get 408. Now, here's the mistake that people make. They just go 144 plus 289 minus 408. Well, that looks great, but if you think about order of operations, multiplication of 408 and cosine C takes priority over subtraction, and so that would violate our order of operations and we would get the wrong answer. So instead, we can subtract 144 from both sides. We can subtract 289 from both sides. If you do make an order of operations mistake, what might happen sometimes is you might end up with an error on your calculator when you get to the end. Other times you'll get the wrong answer and you won't know that it's wrong. You just don't realize your mistake. 400 minus 144 minus 289 is negative 33. Next, let's divide both sides of the equation by negative 408, and I'm just going to rewrite it with the variable on the left because I just kind of like it that way. Now, of course, we don't need negative divided by negative. We can make that positive. But I didn't put it in my calculator yet. I'm just calling it 33 over 408. And now we're going to find the inverse cosine to get C by itself. So this is what goes in the calculator. Inverse cosine of 33 over 408. Inverse cosine of 33 over 408 is 85.4 if we round to the nearest tenth. Let's store that. Store alpha C, enter. Okay. I forgot what it was. 85.4. Okay. So, 1 down, 2 to go. Let's find another angle. And to do that, it doesn't matter if we choose to find angle A next or angle B next, so just take your pick and use the law of sines. I'm going to find angle A next. So 12 over the sine of angle A equals 20 over the sine of 85.4. And I'm going to use the stored 85.4, not the rounded one. You'd be surprised how much it throws off your accuracy just by rounding that one little thing. All right, so let's cross multiply. So we have 20 sine A equals 12 sine of 85.4 stored. And then divide by 20. And then find the inverse sine. So this is what's going to go in the calculator. And for that, we get approximately 36.7 degrees. Now, I want to store that one as well. So store alpha A, enter. And next, the last thing we have to do is find the measure of angle B. So that's going to be 180 minus our stored angle A, don't use the approximate one, minus our stored angle C, don't use the approximate one. Sometimes what we'll find is all of these approximate answers will add to something like 180.1 or 179.9 because we approximated them all, whereas in theory they should all add to 180, but don't let that throw you off. So we have 180 minus our stored angle A minus our stored angle C, 57.9. Okay. So there's an example of how you use the law of cosines to find an angle, and then once you have that, you can switch to the law of sines to find the next thing. So for your homework assignment, we have just a small list of 5 problems to do. Thanks, everybody.